So hi guys, today we'll be seeing unit 17 and 19 biochemistry. Okay, so that is aldehydes and ethyl alcohol. So first we'll complete unit 17 and then go to unit 19. So ethyl alcohol. Okay, so alcohol you already know that hydroxyl group with hydrocarbon group with OH as its carbonyl compound is alcohol. Okay, ethyl alcohol is nothing but two carbon atoms. It has two carbon atoms with an alcohol OH atom. Okay, so that is ethyl alcohol. So the formula for ethyl alcohol is C2H5OH. Okay, so two carbon atoms C2H5OH. So how is ethyl alcohol prepared from molasses? Okay, so molasses is nothing but cane juice. Okay, from sugar canes. Molasses is nothing but the waste product after which comes after the sugar cane juice. Okay, when sucrose is crystallized from concentrated sugarcane juice, dark brown colored mother liquor is left, which is called as molasses. So it is diluted with water, acidified with dilute sulfuric acid, and then ammonium sulfate is added. Then yeast is added and temperature is kept about 30 degrees Celsius for 2 to 3 days. Okay. So for basically fermentation process. So for fermentation, yeast is added and kept for 3 days, 2 to 3 days. So ethanol, that is ethyl alcohol, is formed by fermentation. The contents are filtered and the filtrate is distilled. So this is your reaction for that. So C12H22O11 is a sucrose. Okay, it's the same for sucrose plus water. Okay, so invertase is the name of the reaction. So sucrose plus water gives us glucose plus fructose. Okay, glucose and fructose, it breaks down into small compounds. Then glucose on adding symmetry, that is yeast, we get ethyl alcohol plus carbon dioxide. Okay, so carbon dioxide, that up arrow mark is indicating that carbon dioxide escapes as a gas. So this is the reaction. Okay, so this is how you prepare ethyl alcohol in laboratories. So next we'll be seeing about chloroform. Okay, so chloroform is prepared in the lab by the reaction between ethyl alcohol with bleaching powder, followed by the distillation of product chloroform. Okay, when ethyl alcohol reacts with bleaching powder, the product is chloroform. Okay, so bleaching powder acts as a source of chlorine and calcium hydroxide. So the first step is oxidation, that is ethyl alcohol C2H5OH plus chlorine is added. Okay, so what we get is acetaldehyde plus hydrochloric acid. Okay, the next process is chlorination, in which we add chlorine. So in acetaldehyde, if we add chlorine, we get the product acetaldehyde trichloro. Okay, sorry, trichloroacetaldehyde. The product is trichloroacetaldehyde plus hydrochloric acid. Again, that trichloroacetaldehyde, it is also known as chloral. Okay, it is reacting with calcium hydroxide, that is CaOH twice, to give us chloroform, that is CHCl3 is chloroform. Okay, plus the byproduct, that is CaHCOO twice. So I am again repeating it. Write and see the reactions 10 to 15 times. Then only you keep in mind. Okay, then only it comes to mind when writing the exams. Do not orally study the reactions. Write and see the reactions. Okay. So what are the chemical properties of chloroform? So oxidation. Okay. So chloroform undergoes oxidation in the presence of light and air to form phosgene. Okay, that is carbonyl chloride. COCl2 is known as phosgene or carbonyl chloride. Since phosgene is very poisonous, its presence makes chloroform unfit for use as anesthetic. So that's why before uh, uh, before knowing that phosgene is formed for anesthetic purposes, chloroform were used. But after finding out, after researching that the chloroform gives out phosgene while oxidation, that is in the presence of oxygen. Nowadays chloroform is not used as a anesthetic agent. Okay, so chloroform plus half O2, okay, in the presence of air and light gives phosgene plus hydrochloric acid. Both phosgene and hydrochloric acid is harmful to human body. So that is why nowadays chloroform is not used as an anesthetic agent. Okay, so 1 by 2 O2, it is given as half O2 to just balance the equation. Okay, next is reduction. Chloroform undergoes reduction with zinc. Okay, reduction is nothing but what to say, gain. Okay, gain of hydrogen or gain of electrons. Okay, so oxidation is loss of electrons. that is Leo and Ger. Okay, Leo means loss of electrons is oxidation, and GER, gain of electrons, is reduction. Okay, so in reduction, chloroform undergoes reduction with zinc and hydrochloric acid, the presence of ethyl alcohol to form methylene chloride. Okay, so chloroform has two hydrogen, that is H2. The presence of zinc and hydrochloric acid gives us methylene chloride plus HCl. Okay, so the same reaction is repeated. Okay, there's the same reaction, so no need to worry, this is a single reaction. So these are your oxidation and reduction properties of chloroform, that is chemical properties. So in the exam, if they ask you, write the chemical properties of what is it, chloroform, you have to write chemical properties. Number one is oxidation, you have to write this, and again number two, reduction, you have to write this. Okay, only one reaction is enough. Okay, both are same reaction. So what are the uses of chloroform? Chloroform is used as a solvent. Okay, a substance that helps other substances dissolve. Okay, so it is used in the building and is used in building, paper and board industries, and pesticide and film production. Okay, it is also used in, for production of films. So films is nothing but that photography films. Okay, the production of that films, and also in the development of pesticides. It is used as a solvent for lacquers, floor polishes, resins, adhesives, alkaloids, fats, oils, etc. etc. Okay, so these are the parts. These are the industries and places where chloroform is used. Okay, do not write chloroform is used as anesthetic agent. Okay, that is very wrong. Chloroform is nowadays considered very poisonous and not used as an anesthetic agent. So next, bleaching powder. Okay, so bleaching powder is prepared, okay, by the reaction of milk of lime with chlorine. Okay, milk of lime is nothing but calcium hydroxide. Okay, calcium hydroxide, CaOH twice. The chemical name of bleaching powder is calcium oxychloride. Okay, so calcium oxychloride, that is your chemical name for bleaching powder. So the reaction, 2CaOH twice, that is calcium hydroxide. CaOH twice is calcium hydroxide or milk of lime or slaked lime, plus chlorine gives us CaCl2, calcium chloride, plus bleaching powder, that is calcium oxychloride, plus the byproduct is water in this reaction. Okay, so this is how bleaching powder is prepared from calcium hydroxide and chlorine. So since we are adding chlorine to this reaction, it is also considered as a chlorination reaction. So chemical properties of bleaching powder. Okay, on long standing, it undergoes auto oxidation into calcium chlorate and calcium chloride. Okay, so it undergoes auto oxidation. Okay, on auto oxidation means it's a oxidation occurs without the help of external factors. Okay, it undergoes auto oxidation when oxygen is present and converts into calcium chlorate and calcium chloride on account of the formation of nascent oxygen. It shows oxidizing and bleaching properties. So what are uses of bleaching powder? You all know that it is used as a disinfectant for cleaning and germicide, especially in the sterilization of drinking water, for the manufacture of chloroform, for making wool unshrinkable, as an oxidizing agent in the industry. Okay, so these are the main important four uses of bleaching powder. Next is iodoform. Okay, so how do you prepare iodoform? Iodoform, the formula for iodoform is CHI3. Okay, when ethanol is warmed 60 degrees Celsius with iodine in the presence of an alkali, that is sodium hydroxide or Na2CO3, iodoform is obtained. Okay, so ethanol C2H5OH plus iodine plus 6NaOH, that is sodium hydroxide, gives us iodoform plus the remaining byproducts when it is heated to 60 degrees Celsius. Okay, if you are writing the answer for this question, the preparation of iodoform, if you are not writing that above paragraph, then it is heated to 60 degrees Celsius. If you are just writing the reaction, it is wrong. Okay, so if you are just writing the reaction, what you have to include in the reaction is, you have to include 60 degrees in the top of that arrow mark, indicating that it is heated, that the reaction is occurring at 60 degrees Celsius, not at average room temperature. Okay, you have to indicate that the reaction is happening at 60 degrees Celsius. Okay, so what are the uses of iodoform? On a small scale, iodoform is used as a disinfectant. It is an active ingredient of making cat and dog powders along with zinc oxide and propanoic acid, which are used in order to prevent infection. It also facilitates the removal of ear hair. Okay, so the chemical properties of hydroform. On heating, hydroform decomposes to give iodide vapors, hydrogen and carbon. Okay, so CHI3 on heating separates into C plus Hi plus I2. That is iodide plus hydrogen. Sorry, it's not I2 plus Hi plus C. It is I2 plus H plus C. Okay, make a note of it. I2 plus H plus C, not Hi. On treating with sodium arsenate and sodium hydroxide, it gets reduced into methylene iodide. Okay, so that is your reaction. Okay, so these are your chemical properties of iodoform. So next is benzyl alcohol. Okay, so benzyl alcohol, I have already told you alcohol is OH. Okay, alcohol group is OH and benzene means it has a benzene ring, that is C6H5 ring. Okay, so the formula for benzyl alcohol is C6H5CH2OH. That is your formula for benzyl alcohol. So benzyl alcohol is produced industrially from toluene via benzyl chloride, which is hydrolyzed. Okay, so benzyl chloride is C6H5CH2Cl. Okay, plus H2O gives us benzyl alcohol plus hydrochloric acid. So this is your industrial preparation. Okay, of benzyl alcohol. So chemical properties. The reaction between carboxylic acids and benzyl alcohol leads to the formation of esters. Okay, when benzyl alcohol reacts with carboxylic acid, it leads to the formation of esters. This compound undergoes a Ritter reaction with acrylonitrile toluene in benzyl acrylamide. Okay, so these are your chemical properties of benzyl alcohol. So what are the uses? Where are benzyl alcohol used is a solution of benzyl alcohol with a concentration of 10% can be used as a local anesthetic and also as an antimicrobial agent. Okay, so local anesthetic, you already know what is a local anesthetic means. Just anesthetizing or making a specific part of the body. Okay, so if you are going for a dental operation or something like that. Okay, if you are going for a dental operation or something like that, they put an injection, right? They put an injection in the gums of our teeth. Only our mouth gets numb. Okay, so so for those uses benzyl alcohol is used. And it is used in the manufacture of soaps, shampoos, and skin lotions because of its antifungal and antibacterial properties. Okay, so for some fungal infection in skin, hair, or something like that, it is used in the manufacture of those antifungal. So because of those antifungal properties, it is used in the manufacture of soaps, shampoos. Okay, so antifungal soaps, antifungal shampoos, the dermatology things. Okay, so guys, this is your 17th unit, ethyl alcohol. So I've told you, right, these are all very very small units. Okay, so it is very easy for you to read this. Okay, but just don't make the mistake that only reading is enough. Write and see the reactions 10 to 15 times. Okay, so then only you'll get an idea how to write reactions, how are equations balanced, and etc. And if you have doubts, if you want to know more in depth about organic chemistry, this phenols or something like that, just contact me. I'll just give you some video links. Okay, for in depth understanding. So very deep understanding. Okay, so next we'll be moving to unit 19, aldehydes. Okay, so what are aldehydes? So aldehyde is any class of organic compounds in which a carbon atom shares a double bond with a oxygen atom, a single bond with hydrogen atom, and a single bond with another atom or group of atoms. So that another atoms or group of atoms is indicated as R. Okay, in general formulas. So that is known as aldehyde. So what it basically means is, from the diagram you can understand that carbon atom has this junction is, you have a carbon atom. So double bond with the oxygen atom, a single bond with the hydrogen atom, and another single bond is to any group of atoms. The double bond between carbon and oxygen is characteristic of all aldehydes and is known as the carbonyl group. Okay. So if carbon has double bond with oxygen, it is known as carbonyl groups. So many aldehydes have pleasant odors, and in principle they are derived from alcohols by dehydrogenation, that is removal of hydrogen, from which process came the name aldehyde. Okay. First we'll be seeing about formaldehyde. Okay. So formaldehyde, the formula is HCHO. Okay. So that is formaldehyde. So how do you prepare formaldehyde? It is produced industrially by the catalytic oxidation of methanol. Oxidation means loss of electron per gain of oxygen of methanol. Methanol is nothing but methyl alcohol. Okay, CH3OH. The most common catalysts are silver metal or a mixture of iron and molybdenum or vanadium dioxide. Vanadium oxide. Okay, so those are your catalysts. So oxygen means addition of oxygen, right? So 2CH3OH plus O2 in the presence of silver or iron when heated to 250 to 400 degrees Celsius gives you formaldehyde, HCHO. Or formaldehyde can also be generated by oxidation of methane. Okay, but this route is not industrially viable because the formaldehyde is more easily oxidized than methane. So what it generates is, this method is not used for industrial preparation, that is large scale preparation of formaldehyde. Okay, so methane when oxidized, that is CH4 plus O2, gives HCHO, that is formaldehyde. So what are the chemical properties? So formaldehyde reacts with base like sodium hydroxide, forms sodium formate and methyl alcohol. Okay, the chemical reaction is, that is 2HCHO plus sodium hydroxide gives you HCOONA plus CH3OH. Next, formaldehyde reacts with ammonia, forms forma formamidine and water. Okay, so ammonia is nothing but NH3. Okay, so HCHO plus ammonia gives CH2 6N4. Okay, CH2 6 times N4, so that is your formamidine. Okay, so what are the physical properties of formaldehyde? It has a suffocating odor. Okay, odor. The odor is nothing but smell. It is a colorless gas. It is soluble in water and acetone. So uses of formaldehyde. So 40% aqueous solution of formaldehyde is called as formal. Not that is nothing but 40% formaldehyde and 60% water. So that is 40% aqueous solution. Okay. So if you are taking 1 liter, 400 ml of formaldehyde and 600 ml of water is 40% aqueous solution of formaldehyde. That 40% aqueous solution of formaldehyde is known as formalin. So it is used for preserving biological specimens. Okay. In the biology lab, you see specimens preserved in a liquid, right? Those liquids are formalin. Okay, so that liquid is formalin. 40% aqueous solution of formaldehyde. So formalin has hardening effect. Hence it is used for tanning leathers. Okay. So tanning leathers means making the leather hard. So formalin is used in the production of thermosetting plastic known as bakelite, which is obtained by heating phenol with formalin. Okay. So thermosetting plastic is the plastics used in phones, cell phones, landlines, something like that. Okay. So those are all known as thermosetting plastics. Okay. Used in the production of thermosetting plastic. That is name of bakelite. So it is obtained by heating formalin with phenol. Okay, formaldehyde on the whole is not very useful, but 40% aqueous solution of formaldehyde is very useful as a formalin. Okay, next we'll be studying about acetaldehyde. Okay, C2H4O, that is acetaldehyde. So preparation. Okay, so this is a very important reaction. Okay, Rosenmund reaction. They will not ask preparation of acetaldehyde from acetyl chloride or something like that. They can also ask write the Rosenmund reaction. Okay, so while writing and seeing the reaction, also write their name of the reaction. If that reaction has a name, write the name of those reactions. So acetaldehyde can be prepared by the hydrogenation of acetyl chloride in the presence of palladium supported by barium sulfate. Okay, so in this reaction barium sulfate acts as a catalytic poison to palladium catalyst, so that aldehyde cannot be further reduced to alcohol. So what this Barium sulfate its job is it acts as a catalytic poison. Catalytic poison is some nothing but a compound which stops the process of a catalyst. Okay, so it is stopping the process of the catalyst, that is in this case palladium, so that the acetaldehyde does not get further reduced to alcohol. It stays in the aldehyde form. So acetyl chloride plus hydrogen. Okay, in the presence of palladium and BaSO4, that is barium sulfate. Here, palladium is your catalyst and barium sulfate is your catalytic poison. Produces acetaldehyde as the main product and hydrochloric acid as your byproduct. Okay, so this catalyst and catalytic poison is very important. You have to mention it while writing the tests. So, physical properties of acetaldehyde. So, acetaldehyde appears colorless and has a strong odor liquid. Okay, so those are its boiling and melting point. Okay, the density is 0.784. So, however, acetaldehyde is soluble in visible water, ethanol, benzene. It is also slightly soluble in chloroform. So, chemical properties of acetaldehyde. By a condensation reaction, we can gain intermediates such as pentaerythrol, that is intermediate in explosives manufacturing, that is manufacturing of bombs, explosives, and dynamics, that we can use in organic synthesis, used to produce hydroxyethyl derivatives through a reaction with a Grignard reagent. Acetaldehyde is an important and building block that we use in the synthesis of heterocycles such as imines and pyridines. Okay. So uses, where is acetaldehyde used? It is used in the silvering of mirrors. So silvering of mirrors is nothing but if you are looking at a shaving mirror, you can see only your face reflecting backside. So if you turn the backside of a mirror, you can see a silver coating to stop the light waves from refracting through the glass. So that silver coating is acetaldehyde. Paraldehyde is used as a medicine as hypnotic. Okay, it is used as a hypnotic agent. It is used in the commercial preparation of number of organic compounds like acetic acid, ethyl acetate, and many other compounds. Okay. So next we will be seeing about benzaldehyde. So I've already told you that the name benzene comes. It is denoting a benzene ring, that is C6H5. So the formula for benzaldehyde is C6H5CHO. It is the simplest representative of the aromatic aldehydes. Okay. So it occurs naturally as glycoside amygdalin. Okay. It is naturally occurring as glycoside amygdalin. So how do you prepare benzaldehyde? Okay, side chain oxidation of toluene and its derivatives by strong oxidizing agents such as potassium oxide gives benzoic acid, that is KMnO4. Okay, when chromyl chloride is used as an oxidizing agent, toluene gives benzaldehyde. This reaction is called ETHYL reaction. Okay. So the reaction you are seeing in the bottom is known as ETHYL reaction. The name of this reaction is ETHYL reaction. Okay. So physical properties. So benzaldehyde is a colorless liquid with an odor of almond oil. Okay, it smells like almond oil. It has a melting point of minus 26 degrees Celsius and a boiling point of 179 degrees Celsius. So it is only slightly soluble in water because there is not much hydrogen bonding present in benzaldehyde, and it is completely soluble in ethanol and diethyl ether. Okay, so compounds which have high number of hydrogen bonding are completely soluble in water. Okay, so chemical properties. The first is Cannizzaro reaction. Okay, so this is an important reaction. It can be asked as write the Cannizzaro reaction or what happens when benzaldehyde is treated with potassium carbonate. Okay, so when potassium carbonate, that is potash, okay, it is also known as potash, is treated with benzaldehyde, it gives out benzyl alcohol and potassium benzoate. Okay, so that is your reaction, Cannizzaro reaction. Okay, so uses of benzaldehyde, it is used as a flavoring agent. It is used as artificial flavoring agent. Okay, it is also used as in perfumes. I already told you that if it has a benzene ring, hydrocarbon, any chemical compound which has a benzene ring is used in the production of perfumes, because it is also known as aromatic compounds, because their smell will be very pleasant to smell. Used in dye intermediates. Okay, they are also used in dye intermediates. So, starting material for the synthesis of several other organic compounds like cinnamaldehyde, cinnamic acid, etc. So, let's just see a recap of those two units we have seen. Okay. So, ethyl alcohol is nothing but C2H5OH. Ethyl means two carbon atoms, right? Alcohol OH. So, C2H5OH. So, ethyl alcohol is prepared from molasses. The question can be asked is, how is ethyl alcohol prepared from molasses, or how is ethyl alcohol prepared from sucrose, or how can ethyl alcohol be prepared by fermentation? Okay. So, these are the types of questions can be asked. So, next, studying about chloroform. So, this is how we prepare chloroform from ethyl alcohol. First step is oxidation. The next step is chlorination, and the third step is hydrolysis. So the chemical properties. So this is your oxidation reaction. Okay, when chloroform oxidizes, it forms phosgene and hydrochloric acid, and while reducing, it produces methylene chloride. So these are the uses of chloroform. Next is bleaching powder. Okay, so the chemical name of bleaching powder is calcium oxychloride, and the formula is CaOCl twice. Okay, CaOCl twice. That is your chemical formula for bleaching powder, and the name is calcium oxychloride. So this is the preparation of bleaching powder. Okay, so this is how bleaching powder is prepared from calcium hydroxide or slaked lime or milk of lime. So chemical properties and its uses. Then iodoform. Okay, so in this reaction, while writing, you have to remember that in the top of the arrow mark you have to write 60 degrees Celsius. You have to mention the temperature at the top of the reaction. So on heating, iodoform reduces into iodine plus hydrogen plus carbon. In this note, take note, it is I2 plus HI. Yeah, it's HI. Okay, so it's not hydrogen alone, it is HI plus carbon atoms. Okay, so benzyl alcohol. Okay, benzene means C6H5. Okay, that is your benzene thing. Okay, so benzyl alcohol C6H5 CH2OH. So this is how benzyl alcohol is prepared. Okay, so those are the chemical properties and uses of benzyl alcohol. Next, going back to aldehydes. So aldehyde is a hydrocarbon in which the carbon atom and the oxygen atom are attached by double bonds, and a single bond is attached from the carbon to the hydrogen atom, and another single bond is attached from the carbon atom to any other atom or a group of atoms. Okay, so in which carbon atom shares a double bond with an oxygen atom, a single bond with a hydrogen atom, and a single bond with another group of atoms or atom. So that is your aldehyde. Okay, so the first formula for a formaldehyde is HCHO. Okay, so these are the preparation of formaldehyde. Two types of preparation. The first is your industrial preparation. Okay, then second is your laboratory preparation. So in the second type of preparation, that is from methane, formaldehyde cannot be prepared industrially. That is in large scale. So those are your chemical properties of formaldehyde, and that is your physical properties. Okay, just make a note that all the gases and liquids you have studied up to now, their physical properties is they have no color. Okay, it is either a colorless gas or it is either a colorless liquid. So uses formaldehyde on its own is not as much as useful, but 40% aqueous solution of formaldehyde, known as formalin, is very useful. Okay, so the main important use of it is for preserving biological specimens in biological labs. So next is acetaldehyde, C2H4O. Okay, so this is your preparation of acetaldehyde from acetyl chloride, or write about the Rosenman reaction. Okay, it can be asked as any name. So acetyl chloride plus hydrogen, the presence of palladium as the catalyst and barium sulfate as a catalytic poison. Okay, you have to mention those points. Okay, if it is asked as Rosenman reaction, you have to both write the paragraph and the reaction. Okay, so physical and chemical properties of acetaldehyde, then uses. Okay, so its main uses for silvering of mirrors. Okay, now benzaldehyde, that is benzene ring, C6H5 plus CHO. This is your preparation of benzaldehyde. Okay, from methyl benzene. So this is also a colorless liquid. Okay, since it has a benzene ring, it has to have some pleasant smell, right? So benzaldehyde has the smell of almond oil. Okay, and the chemical properties, this Cannizzaro reaction is very very important. Okay, so when benzaldehyde is treated with potash alum or potassium carbonate, it gives benzyl alcohol and potassium benzoate. So it is used as a flavoring agent, and likewise, and for writing uses. Okay, when you see a benzene ring, that is in the name, when you see benzene or phenyl or something like that, just write the uses that it is used in the manufacturing of perfumes. Okay, all compounds which have a benzene ring or a phenyl group, okay, that is C6H5, all compounds with a CC6H5 is used in the production of perfumes. Okay, each has a different smell, and each is used in different kinds of perfumes. Just make the note. Okay, this is very important. It can be also very useful in exams. Okay, so if you have the name benzene in anything or phenyl or something like that, just in the users mentioned, it is used in the manufacture of perfumes. So here benzaldehyde, it is also used as synthesis of several other organic compounds like cinnamaldehyde, cinnamic acid, etc. Okay, so that's it for today, this class, guys. So unit 17 and 19 is completed for you. If you have any doubts, feel free to ask me. Okay, do not hesitate. Feel free to ask me. Thank you.